Hello friends, allow me to start by setting up a small postulate. Pi is an exponential and cyclic number, which means that cycles of powers of pi can adjust and measure all other parameters of the circumference. And with this we can establish a slightly broader theorem, which would be all the parameters of a given circumference, of radius 1, as well as all the parameters of its squares and circumferences inscribed and circumscribed on it, till infinity, can be adjusted and measured by means of powers of the squaring pi, with application of a decimal reduction coefficient, 10 to the power of n, to place the value of the searched parameter at its appropriate level. For example, pi caret 34 equals 8 multiplied by 10 to the power of 16, and therefore being the squaring pi equals 3.14159144414199265, where 8 is the square circumscribed to the circumference, and 10 to the power of 16 is the decimal reduction coefficient. In this diagram, we can see how power cycles of pi can give us all the squares and circumference circumscribed between them to infinity, applying the appropriate decimal reduction, and how the current algorithmic pi cannot. The mathematical, and perhaps philosophical, reason for the application of a decimal reduction in the powers of pi is that the peculiarities of the decimal system make the high powers tend to take enormous values, when what the number pi needs is that the cycles of powers that maintain values close to unity, an issue that is solved with the decimal reduction, that is, without moving away from radius 1 that creates the parameters of the circumference. The birth of an idea, the cyclic pi. Friends, I am frequently asked about the initial idea for cyclic pi. At first I called it squaring pi, 2009. Well, the idea arose me thinking about the nature of the number pi and observing a drawing similar to the one that I expose here. And the question that assailed me was quite clear and forceful. How is it possible that the geometry of the circumference and its pi value go one way, constructed and contained by its radius, diameter, inscribed and circumscribed squares, and the arithmetic adjustments go the other very different way, by endless series of fractions, not relative to the anterior parameters? How can arithmetic not be able to build a formula that interrelate, deduct and extract all its construction parameters among them, including the number pi, as in all other geometric figures? I said no, that's not possible, surely that formula exists, but we haven't discovered it yet. And then I asked myself, how should that formula be? Logically by powers and roots, which is as curves are built in Cartesian coordinates. For example, y equals x caret 2. And what parameter of the circumference seems to be the one that has been subjected to roots, observing its irrational results? Of course, the number pi seems to be. Then logically, I need to proceed in the opposite way. I will subject pi to continuous powers until I find some other rectilinear value of the previous parameters. And not too late after, a strong approximation to a supporting parameter of the circle appeared to me, which is its semi-inscribed square, 2.sqrt.2. And since then I have been building the connections, formulas, cycles, properties, etc. of this cyclic number pi. And of course, coming to the conclusion that the cyclic pi is the right pi number. I don't think the other pi by series has any chance of being correct, because it is complicated, disconnected, endless, ethereal, with methods, series, unconnected and far from the value of the construction parameters, and why not, transcendental, and not regular. The pi squared cycle. Because it is an important demonstrative proof for me, first allow me a simpler explanation. The pi squared cycle is a circuit or mathematical cycle to check the accuracy of the pi number that we apply. Geometrically we can suppose a roulette circuit, with the dimensions of pi squared, and on which we make the ball of this roulette circulate, exponentially increasing in each turn the possible inaccuracies of this value, in such a way that if the pi applied is exact, the circuit remains unchanged indefinitely, but if the applied pi is not exact, the circuit will wobble and quickly be destroyed. And now let's look at it a little more extensively. The pi squared cycle, roulette or pi trap. Accuracy test. Preamble. For many years I have been surprised by the apparent persistence of the number pi in hiding and escaping from a clear sample of its definition and mathematical demonstration through formulas that show us its true value and situation. However, and from this cyclical formula or function, my feeling has changed and my doubts have been cleared, and I understand that the number pi can tell us. Well, here I am, enclosed, located and measured by my own construction parameters. Do you see me now? Friends, as some of you already know, I have my own point of view and proposals for the number pi. I understand that it has an irrational value, but not transcendental, and that it is totally related, integrated and measured by the construction parameters of the circumference, diameter, inscribed and circumscribed squares, etc. During these years of considering it like this, I have been able to verify that it has more logic and with greater mathematical and geometric properties than the algorithmic pi that is currently used. So let me present one of these particulars that I find interesting, and that would also represent a proof of its validity. It refers to what I call the cycle of pi squared, and which relates the square circumscribed to the circumference, 8, with the number pi of its inner circumference, and in which the operating decimal number, 10, is used to maintain the level of operations, of powers and roots, close to unity, that is, at the level of the dimensions we are using. This cycle function is simple, and as the name implies, it is cyclic since the input result of the mathematical function is the same as the output result, if the correct number pi is applied. It is represented geometrically by a cycle or roulette on which we can rotate or maintain the circumference of the square of pi without its value changing with the cyclical function that is applied to it. However, if we add a non-exact value of pi to this loop, then the circumference of pi squared is quickly distorted and destroyed. Simplifying, the cycle would be like a tour in continuous rotation around a circle of value pi squared, in which tour this value of pi squared is analyzed and tuned or increased in error at each turn by the function exposed cyclic in such a way that if we have applied the correct value of pi, the cycle and the value of the circumference remain unchanged indefinitely. But if the applied pi is not correct, the circle wobbles and is destroyed quickly, or faster, when greater the error in the applied pi. Asterisk in the same sense, with a variable of this cycle, and with a correct number pi, we must measure, through powers and roots, all the squares and circumscribed circles on a first given circumference. Demonstration and testing. As we can see in the drawing, the effectiveness of this pi squared cycle is very high, since although the algorithmic pi currently used is very approximate, when we submit it to the pi squared cycle test, already for the fourth return to the cycle is destroyed and out of the loop. And if we use only the approximate value of pi equals 3.14, the value of the cycle, pi⁻², is destroyed in the first loop. On the other hand, the squaring pi remains intact, which in my point of view is a clear demonstration of its validity. Discussion and logical and philosophical proof on the cyclical pi. Geometric and arithmetic similarity in the cycle of pi squared. Suppose hypothetically that a person who has never made a circle begins to build it by turning the compass and perhaps wondering if, at the end of the turn, the return line or point will completely coincide with the starting line or point. But, once he checks the total coincidence and the closure of the circumference, he will rest and realize that all the devices and construction parameters are correct and have not varied throughout the drawing. Well, the same happens arithmetically with the pi-squared cycle formula, which we check that the output and return value of the cycle coincides with the input value, pi squared, and therefore that all the elements and parameters, pi value applied, are correct and suitable for the construction of the perfect circle, pi squared. And as we can see, this value of pi corresponds exactly to the value of cyclic pi. In the case of the geometric construction, the devices would be mainly the compass, and the interrelation parameter, circumference diameter, would be the value of pi. And in the case of arithmetic adjustment, there would be no physical devices, but rather the formula of the squared pi cycle and the pi parameters as well as the value of the square, 8, that contains, delimits and joins the number pi and the diameter. So, geometrically, with the compass and the value of pi that it develops, we complete or close a perfect circle. Arithmetically, with the cycle pi squared, substitute for compass, and the correct value of pi, we equalize and close a perfect circle. Some examples. Next, I put drawings of how to use the squaring pi cycles to obtain simple parameters of the circumference, although they can be extended to obtain values of all the squares and circles circumscribed between them. Likewise, I put some curious examples such as the squaring pi pyramids. Well friends, thank you very much for your interest and kindness.